Hi all. So today we are going to look at loops and iterations in Python. Okay, and so this slides I have been taken from Python for Everybody and by Chuck Severance. So we will use these slides to explain the different loops and iterations in Python. So what is the need of a loop? Let's say I want to print the numbers from 1 to 10. So what will I do? So I will just print, I can say print 1, print 2 and go on till print 10. Okay, that is the simplest way. What about I want to print numbers from 1 to 1 million? So then I need to write 1 million such print statements, which is a very tedious job. You can copy paste, but still you need to change the values inside the print statement. So to do such iterative process, iterative means something which is repeating. To do such iterative tasks, you can use loops. Loops are basically called as repeated steps. You might have studied loops in C, which is basically two types of loops. First is while and the second is for. And luckily for Python also we have the two types of loops, which is while and for. And it is not complicated. The syntax is a bit different, but otherwise everything else almost remains the same. Okay, so let's look at first the while loop. Okay, so syntax of while loop is, you can have while the condition. So this is basically the condition and the body of the loop. So this is the loop body. So what is loop body? If the condition is satisfied, what should be executed? That is the loop body. So if you look at this program, you see initially you have n equal to 5. Okay, then you are checking if n is greater than 0. The condition is correct. So it will enter the body. So you should have one tab space, ideally 4 spaces, after which you should write the statement for the while loop. So here you are saying you should print the value of n. Okay, and then put another tab space because you are going to write the next statement as the loop body, and you are decreasing the value of n. So initially the value of n is 5 and you printed that. You go to this statement. Now you are saying n equal to n minus 1, which means the value of n, the new value of n should be 1 less than the previous value, which is 4. So the loop, after executing this statement, it will come back to the while condition. You will check the condition. The new value of n is 4. Is 4 greater than 0? The answer is yes. So the condition is true, which means it will come back inside the loop statements or loop body, and it will execute the next statement, which is print n, which means it will print 4. Again, it will go inside, like it will go to the next statement, decrement n by 1, which is this statement. It will become 3 now. Again goes back to the while condition, while 3 less greater than 0, it is true, comes back in, it will print 3. Similarly it goes and again it loops around. It will reach a value when n equal to 1. So when n equal to 1, 1 is greater than 0, that is correct. It will print n, that is 1. Now 1 minus 1 will be 0. So new value of n will be 0. It will go back to the while condition. You will check what is the value of n. So 0 greater than 0, this is false. So the condition became false. So it will exit the loop. It will not execute any of the statements inside the loop body. It will directly come to this statement and it will print blast off. And finally, it will print the value of n, which will be 0. Okay. So this is how the loop works. The loop will, whatever is inside the loop body will execute till the condition of the while statement becomes false. Okay, fine. The n, the value n is called as an iteration variable because it is the value which changes at every loop iteration. Okay, so then can we have an infinite loop, the loop which never ends? The answer is yes. Check this one. So here n equal to 5. So you have a memory location n which has value 5. It checks while n is greater than 0. The condition is true because 5 is greater than 0. So there is a syntax for while in which you need to put a colon. If you don't put a colon, the Python will throw you an error. It goes inside the body. You see, you can identify the body as this part because it is one tab space apart. It goes inside the body. It will print lather. It will print rinse, the second statement. Now the value of n is not getting changed inside, because of which if it comes again, the memory location n still has 5. So 5 is greater than 0, that is true. It goes inside. It will again print, lather rinse. N is still not getting changed, goes back again. 5 is greater than 0, that is true, it comes inside. So you see that the value of n is not changing inside the loop, because of which this is an infinite loop. It never ends. It will end only when you stop, purposefully saying you press Ctrl C or Ctrl Z, it will stop. Okay. So if you look at the flow chart, n is 5, n is greater than 0. Yes, it comes here, it prints here, goes back. N is always greater than 0. It keeps on rotating. It never stops. Okay. So the statement print dry off will not execute. So what is wrong with this loop is it is an infinite loop. If there is an infinite loop, the statement after the infinite loop will never execute. So that is the problem. Okay. What about this one? Here the initial value of n is 0. Then you say while 0 greater than 0, is the statement true or false? This statement is false, because of which this whatever is inside the loop body will never execute, and it will directly jump to the print statement dry off. So if you look at the flow chart, it comes n equal to 0, n greater than 0, that is true, sorry, that is false. It will go to the no part and print this. So this part will never get executed. So what is this loop does? It just prints dry off. It will never execute the loop. So you should always design a loop by carefully choosing the condition and the initial value for the condition. So this is a while loop where you need to specifically say what should be the initial condition for the variable n. Let's say if you don't have this statement, now the value of n is ambiguous. You don't know what is the value of n. Then the loop can do what the compiler tells him to do. So sometimes the compiler will assign n equal to 0 initially, then it will not go inside. Sometimes the compiler will assign n a garbage value, or most probably the compiler will throw an error saying that the n has never been assigned. So you should always initialize the loop variable before doing anything. So if there is an infinite loop, let's say there are situations in which you need to have an infinite loop, and you should come out of the loop only if some condition satisfied, but you don't know when the condition will occur. For example, in while n greater than 0, you know the condition will occur when n is more than 0. But there are situations where you keep on checking. So for example, you are measuring the temperature. You are keep on monitoring the temperature, and you want to come out of, so there's a while loop in which you are taking the values of temperature. Now you should come out of the loop and tell that you have a fever if the temperature is above 100 Fahrenheit. Okay, so but you don't know when that will happen. So when that happens, you should come out of the loop. So the statement which can break you out of the loop is the break statement. So it ends the current loop and jumps to the statement immediately following the loop. Okay. So let's say this example. So while true means always correct. This is a Boolean true. You might have studied in your logic circuit design where there is something called a Boolean true and false. This is a Boolean true. So this is a keyword which the Python understands, and the T should be capital. Okay, so here what you are saying is line is equal to input, and you are given something like this. Okay, so the user will type, for example, hello there. The user will type hello there. It will be stored inside the line as a string. Now you can compare if line is equal to done. So initially the user types hello there. The line is not equal to done because it is hello there. So the if condition, whatever is statement is inside the if condition, will not execute. It will print the line. So it will print hello there. Again, it comes back. It's always true. Now again, it is asking the user to input something after the greater than sign. It says finished. Again, it will check if you have entered finished, or if you entered done. It is not done, so it will not execute break statement. You come and print the line which is finished. Then when it goes back again, it will go back again. The user inputs done, so it will check if line is equal to done. That is correct. So it will execute the break statement. Once it executes the break statement, it will come out of the loop directly. So whatever statement is after the while loop, it will execute. Okay, the statement outside the while loop. So this is basically your while loop. So once you execute break, it would directly come to this statement outside the while loop, and the while loop now will never execute. Okay, so you see that although this is an infinite loop because of a true statement, you can create or you can come out of the loop by using a break statement. Okay, fine. So this is what I have explained. So if there is a break statement, if it executes by satisfying this condition, if this condition is satisfied, the break statement will execute and comes out and prints done. Okay, if we look at the flowchart, it is true, yes, and if it comes inside the if, it will execute break, it comes to done. So whatever statements is after break will not get executed. Okay, similar to break, there is a keyword called continue. What does continue do? It ends the current iteration and jumps to the top of the loop and starts the next iteration. Okay. So let's do the same example. While true, that is correct, always right. So this asks input from user. So user types hello there. It checks if the first character of the string is hash. First character. So this is checking the first character of the string in line variable is hash. So hello there, the first character of the string is h. So this condition doesn't satisfy. Okay. So it will check the next, go to the next line. So this is same as that we have seen in the previous example. So it will print the line. It will go back. It will go back to the while. Next again it will ask for the user to input. Now the user input hash, don't print this. So the first character in this one is hash. Okay. So this condition is satisfied. So it will come inside continue. Since it find continue, what it does is, instead of executing the next few lines inside the loop, it will directly jump to the start of the while loop. See, the continue and break are totally different. Break will exit the loop, while the continue will not exit the loop. It will go back to the while condition or the while loop starting. Okay, and it starts executing the others again till the break statement is occurred. Okay, so that is what is shown here. So when you have a continue statement executed, it will go back to the while and execute all together again. Okay. So if you look at the flowchart, it comes here, it shows a continue, it goes back to the condition. If it was a break, it would have come here. So the continue will not break a while or a loop, it will directly go back to the condition. Now the problem with while loop is, while you should have a condition. Okay. If you don't give the condition, or you can always, there is always a possibility that this can be an infinite loop, because if you forget to give some, changing some variables depending on the condition inside the body, it will always go to an infinite loop. So if you are using some kind of an infinite loop, if you want to use an infinite loop, then while loop is the best choice. But if you don't want an infinite loop, if you want a definite loop, some loops in which you should have the control to stop, then while loop is not the choice. And for that, you should have the for loop. Okay. So if you have a finite set of things, so that we can write a loop to run the loop once for each of the items in the set using the for construct. For construct means for keyword. These are called definite loops because they will execute an exact number of times. Okay. So definite loops iterate through members of a set. We will see that. For example, for loop variable or iteration variable, in is a keyword. You have some set of numbers in square brackets and a colon. So what does it do? Loop will come inside, it will print I. So initially the I value will be 5, which is this. Goes back, the 5 is taken. Now the I value will be 4, it prints 4, goes back. Now the I value will be 3, it prints 3, goes back. I value will be 2, prints 2, goes back. I value will be 1, prints 1, goes back. Now there are no more values for the I to take inside from this set. So it will come out of the loop and print blast off. So you see, you can print the values 5 to 1 and finally blast off. So this in statement is important because this is the one which will decide what to take for the value or for the loop variable. Okay, so let's see another example. So I have friends. Okay, and in friends I have Joseph, Glenn, Sally. So these are all strings. So you can have, this is kind of a list kind of thing where you can have multiple entries inside the square brackets. Okay, this is like an array that you have studied in C. You can initialize it like this. Okay, now I have a variable called friend. So this is friends and this is friend. When I say friend in friends, the friend loop variable will initially take Joseph, first iteration. So this will be Joseph, goes back to the loop. Then the friend value will take Glenn. So the next value will be, this value will be Glenn. So Happy New Year, Glenn. Again comes inside, goes back. Next value will be Sally. So it comes inside the loop, print Happy New Year, Sally. After that, when it goes back again, you see that this loop is completed. Okay, so since it is completed, it comes out and print done. So that is a definite loop. Okay, so loops, you can do this flowchart. So you see that this statement is hidden inside the for loop. Actually, the value of I is getting automatically chosen from the set by the Python, and we are not doing anything to choose that value. In C, we need to choose the value. Okay, so this I is called as an iteration variable or a loop variable. Fine. Now we have already told that there is a keyword called as in. So the block of code is executed once for each value in the sequence. ഈ സീക്വൻസിലെ ഓരോ വാല്യൂസിനും വേണ്ടിയിട്ട് ഈ കോഡ് എക്സിക്യൂട്ട് ചെയ്യും. ഇതിലെ ഓരോ വാല്യൂ എന്ന് പറഞ്ഞാൽ 5, 4, 3, 2, 1. Once it has finished executing all these values, it will end the loop. Okay, and the iteration variable moves through all of the values in the sequence. Okay, so that is shown in this flowchart. So actually this I value is taking different values. I is equal to 3, 5, 4, 3, 2, 1, which we are not, which the Python will automatically take care. We don't want to specifically say that okay, you should take this value. It will automatically take the values in order how it is populated inside this sequence in the set. So I will not take initially 4, it will always take initially 5. So 5, 4, 3, 2, 1, it will take in that order. Now whatever we have seen till now is a simple one, simple cases. There's nothing fancy, it's very simple, but the loops are always complicated. We do write loops for many complicated purposes. Okay, and the smart way of writing a loop is, first one, you need to initialize the variables. should know, the trick is knowing something about the whole loop when you are stuck writing the code that only sees one entry at a time. Okay, so you should know how the loop is going to work, although the loop takes only one entry at a time. Okay, so you should have an initialization, there should be a for condition or for keyword, and there should be an iteration variable in the data. So previously we have seen the data is like 5, 4, 3, 2, 1, or it is like friends, where friends is already initialized here. Okay, and then inside the for loop, this is called as the body of the loop. So you might be looking for something or doing something for each entry inside the data. Okay, and then you can check the variables. Fine. Let's see another example. So this is print before, so it will print before. For thing is the loop variable in the values this set. So first loop it will print 9, second loop it will print 41, or second iteration, third iteration 12, and keeps on printing up to 15, and finally it will print after. Okay, this is a very simple thing. Now let's see a bit more complicated thing. So I am going to pass some numbers and tell me what will be the highest number. Okay, so what is the highest number or largest number? Okay, if you see like that, you will not be able to identify the largest number, but the system does it like that. Instead, if I show you like this, you can easily see that it is 74. Now, what is the thought process in your mind which automatically identifies 74? So there is some kind of a thought process that is happening inside your mind unconsciously, without your knowledge, which identifies that it is 74. So let's go through that thought process. So initially your mind might be setting some very low value, let's say minus 100, minus infinity, something. Then it will compare minus infinity with 3. So is 3 the largest number when you compare minus infinity with 3? Yes. So your mind will set 3 as your largest number. Then the mind will compare 3 with 41. Is 3 greater than 41? No, 41 is higher. So the mind will change the value inside your box, which is the largest number, to 41. Now you compare 41 with 12. Is 41 greater than 12? Yes. So I don't want to change anything. Then you compare 41 with 9. Is 41 greater than 9? Yes, it is greater than 9. So you don't want to change anything. Then you compare 41 with 74. Is 41 greater than 74? No, it is not greater than 74. So in your box inside your mind, you can just change 41 to 74. Okay. Next you compare 74 with 15. Is 74 greater than 15? No, it is not. So among the numbers, your mind has decided that 74 is the greatest number. So this will happen in your mind in maybe like in 1 nanosecond or maybe less than that. But the system, when you run the code, it will take some good amount of time. So you need to write a logic in which you want to find the largest number. The Python is not intelligent by itself. The intelligence for Python comes from your intelligence. If you are intelligent enough to tell the Python that you compare the numbers and select the largest number, then Python will select the largest number depending on your logic. Okay. So in the program, when you write the largest number, you set largest number as -1. You declare a variable called as largest so far. So allocate a memory, and you initialize it as -1. You haven't started the loop. Okay. Now 3 came. Okay, then you compare -1 and 3. So 3 is largest, so you put 3 inside the block. Similar to how the mind works. Now 41 came. You compare 3 and 41. You know that 41 is largest, so you put 41 inside the block. Now 12 came. Now you compare 41 and 12. 41 is still the largest. You don't want to change anything. 9 came. So you compare 9 and 41. 41 is still the largest, so you don't want to change anything. 74 came. You compare 74 and 41. You see that 74 is the largest, so you put inside the variable 74 as largest underscore so underscore far. And finally 15 comes. You know that 15 is not greater than 74, so you will keep it 74. So among the numbers that is given here, the largest is 74. This is how the logic should work. So how should that be done in the for loop? As I said earlier, you set the initial value. So this is called as initialization, where you set the value as -1. Then you print something saying that before starting the loop, the value is -1. Then you have the loop variable the underscore num. You are giving some numbers. This is hard coding numbers. So what did we do? For each loop iteration, we compared the first number. We compared the number with that of largest so far. Okay. So when you come for the first time, the num value is 9. Largest so far is -1. Is 9 greater than -1? Yes, it is. So you assign largest so far as the number 9. And okay, and you can print the largest so far. So currently the largest number is 9. Now as you move inside, or as you go back again, so because this is a for loop, it will go back again. It has another number 41. So the current largest number so far is 9. So you check 41 greater than 9. That is correct. So the largest number now will become 41. So 41. And this comes back again and keeps on iterating. And finally you will see that for each iteration, the largest number will keeps on changing. So the current number is 41, the largest number is 41. Current number is 12, the largest number is still 41. Current number is 3, the largest number is 41. The current number is 74. Now the largest number will change to 74. And finally, you will see that the largest number is 74. So this is an algorithm in which you can find the largest number from any set. Okay. Fine. So this is a next statement where you are going to count in a loop. For example, you are given this set. You want to count the number of elements in the set. Okay. So again, you set an initialization. Sork is equal to 0. You print before sork, so before it is 0. So each time in the for loop, when it executes, you increment the sork. Okay. First time it executes, the sork value will be 1. You note that thing is the value which is the iteration variable. Sork is totally different variable. So thing is 9. Comes back again. Sork will be incremented by 1, which is 2. When the thing value is 41. Comes back again. Sork is 3 because you are incrementing sork here, and current value is 12, and keeps on repeating till you reach the end 15. So then you have now 6 as sork and 15 as the current value. So number of elements inside the, basically you have counted the number of elements inside this set, which is 6. So to count how many times we execute a loop, we introduce a counter variable. So this source is called as a counter variable. That starts at 0 and add 1 each time. So 0 it will start and it will. Similarly, you can do summing. Okay, so you can look at this code which I will upload and find out how you can do the sum. Okay, so the summing is easy. Initialize, you add Zork with the thing. So initially this will be 9 plus 0, that is equal to 9. So now the Zork will have 9. Next time when it comes, it will add 9 plus 41 because this is Zork and this is thing. So this will be 50, which is assigned to Zork. Next time 50 plus 12. So this is Zork, this is thing. That's equal to 62. And you can keep on repeating till the end and you will see that you will get the total. But make sure that the Zork initialized to 0. If you initialize to anything else, it will cause problem. Now averaging means you find the sum and divide by count. Okay. Similarly, you can do filtering where you can find all the values which is greater than 20. Okay. So in the for loop, you know value will take 9, 41, 12 in each iteration. So in each iteration, you find if the value is greater than 20. First iteration it will come, it will check 9 greater than 20, it is not. Second iteration it comes 41 greater than 20, it is correct, so it will print the value which is 41. Third iteration value will be 12 and 12 greater than 20, it is not. 3 greater than 20, it is not. 74 it will print. So this is like a filtering in the loop. You can choose all those values which you require. You can also do a searching, like for example in this set I want to find out if there is a number with value 3. If there is a number with value 3. So value in the set, I'll check, put an if condition. If value is equal to 3, then you say found true. Okay, so here you will get true. So if you just want to search and know if a value was found, we use a variable that starts at false and set to true as soon as we find that we are looking for. This is value find. Similarly, you can change the largest number finding algorithm to smallest number finding algorithm by making some couple of changes. Okay, so this is the largest finding algorithm. Now what will you do to make it to change the algorithm so that you want to find the smallest number? Now if you do this, only change greater than to less than, it will not work because you are initializing it to the -1 and -1 is smaller to all of them. So it will say that -1 is the smallest. Okay, so instead of that there is an option, so that is the output here. You see, if you change to less than, at all the times it will say -1 is the smallest. So you cannot use this, or you should change the initialization to something called as none. Okay, so in the first time when I come inside, I will check if smallest is none. If it is none, then I will assign the current value. So this will execute only for the first iteration. This if statement will execute only for the first iteration. Okay, and for subsequent iterations it will not execute. Fine, and then it will always go to elif. So this is correct because you are checking the value loop variable with respect to smallest. If it is smallest, then you set the value and print. Okay, so the first time through the loop, smallest is none. So we take the first value to be the smallest. So this first if statement is only to set the first value as the smallest. Similarly, there is two other keywords, is and is not. Instead of saying, or you see that when you say smallest is, we didn't put a double equal to, we said is. So this is a special keyword in Python, is and none, where I can say smallest. You are just speaking in normal English. In normal English, you say if smallest is none, then you do something. Instead, we will not say in normal English is smallest double equal to none. No. When you talk, you say if smallest is none. So that's the same thing that you have put in Python. So it implies that it is same as. It is similar but stronger than double equal to. Stronger matlab means that you can compare a large number of numbers. Similarly, I can also put is not. For example, smallest is not none. That is also possible. Okay. So these are some of the operators and iteration variables that we have looked upon. So make sure you go through the PPT. I have given the basic thing and I have just explained, just went through some of the examples. So we will post some examples in the portal, and maybe you can, or I will post some assignments and you can try doing those assignments using loops and iterations. Okay. So I think that will conclude our session on loops and iterations for Python, and so maybe the next session will be regarding functions in Python. Okay. So thank you for listening.